Welcome to Year 9 Chemistry, Term 1. This is Week 1, Session 1, Matter, Particles, and Scientific Models. Across this course, we will explore states of matter, atomic structure, the periodic table, chemical equations, and acids and bases. Today, we begin with the biggest idea in all of chemistry. Everything around you is made of tiny, moving particles. Let's get started. By the end of this session, you should be able to do 4 things. First, define matter as anything that has mass and occupies space. Second, state the main assumptions of the particle model. Third, compare solids, liquids, and gases using arrangement, movement, and spacing. And fourth, explain why a model is useful even though it is not a perfect copy of reality. Chemists describe the world at 3 connected levels. The macroscopic level is what you can observe or measure. For example, ice has a fixed shape. The particle level describes the atoms, molecules, or ions that are far too small to see. In ice, the water molecules are packed close together. And the symbolic level uses formulae and equations like H2O with the state symbol S for solid. A strong chemistry explanation links an observation to a particle level cause. Saying gases compress only describes saying gases compress because their particles have large spaces between them. Now that explains. The particle model treats all matter as tiny particles, and it makes 4 key assumptions. The particles are always moving, there are spaces between them, they attract one another, and when their kinetic energy increases, for example, when we heat them, they move more rapidly. Keep this in mind. The circles we draw in diagrams are not photographs of atoms. They are a simplification that helps us reason about things too small to observe directly. Let's apply the model, starting with solids. In a solid, the particles are arranged in a regular, closely packed pattern, and each particle is held in a fixed position by strong attractions to its neighbors. That is why a solid keeps a fixed shape in a fixed volume. But look closely. The particles are not motionless. They vibrate constantly around their fixed positions. Now heat that solid until it melts. In a liquid, the particles are still close together, touching in fact, which is why a liquid keeps a nearly fixed volume. But the particles are no longer locked in place. They can slide and move past one another, and that is exactly why a liquid flows and takes the shape of its container. Finally, the gas. In a gas, the particles are far apart and they move rapidly in all directions, colliding with each other and with the walls of the container. A gas has no fixed shape and no fixed volume. It spreads out to fill all the space available. And because there are large spaces between the particles, a gas is easy to compress. Let's put the 3 states side by side. Arrangement, regular and touching in a solid. Random but touching in a liquid. Random and far apart in a gas. Movement, vibration only in a solid, sliding past each other in a liquid, fast and free in a gas. This table is your explanation toolkit. Whenever a question says explain, pick the property and link it to arrangement, movement, or spacing. One more big idea before we finish. What exactly is a scientific model? A model is a simplified representation that helps us explain and predict. The particle model is powerful, but it is not perfect. Real particles are not tiny hard circles. Attractions vary between substances, and particles themselves have structure, as we will discover when we study the atom. A model does not need to be a perfect copy of reality. It needs to be useful. And when better evidence arrives, we improve the model. Time for a quick check. Question 1. Why does a solid keep its shape? Pause the video and answer. Because its particles are held in fixed positions by strong attractions. Question 2. Why is a gas easy to compress? Because there are large spaces between its particles. Here is your recap. Matter is anything that has mass and occupies space. The particle model gives us moving, spaced, attracting particles. And solids, liquids, and gases differ in arrangement, movement, and spacing. In the next session, we will use this model to explain changes of state, diffusion, and density. For the full course with practice questions and the final exam, visit www.brandewexam.com. See you in session 2.